Welcome to Java Object-Oriented Programming Concepts. So introduction to OOP. OOP stands for Object-Oriented Programming, and Object-Oriented Programming is a programming paradigm based on the concept of objects. Objects can contain data and code. Data in the form of fields and code in the form of procedures. So we're going to look at how Java utilizes OOP principles to create modular, scalable, and maintainable code. Java classes and objects. So in Java, the foundation of OOP is the class. What is class? A class is a blueprint for creating objects, and objects are instances of classes and can hold both state and behavior. So, for example, let's consider a car class. We can each car object created from the class can have different states like color or speed, but shares common behaviors like accelerate, or you could even add brake. So if we kind of look at this example more, we can see that this car class is defined with two properties, string color and integer speed, and it has a constructor that initializes these properties when a new car object is created. So you can see that we are passing red and 0 for speed. And the accelerate method here increases the speed by a given increment. And as we explained, an object, my car, is created from the car class and with red as its color and 0 as its initial speed. Encapsulation. So encapsulation is about bundling the data and the methods that operate on the data into a single unit or a class. It also involves restricting access to the inner workings of that class, which is known as data hiding. And in Java, you can achieve encapsulation by defining the class fields as private and providing public getters and setters to access and update the value of a private field. By doing it this way, you can protect the data from direct access by the outside world. Let's look at this simple encapsulation example. We have this employee class with two private fields, name and age. And these private fields cannot be accessed directly from outside a class. So we have this public get name methods and public set name. They allowed controlled access to the name field, and this illustrates the encapsulation we talked about. And we can see that we can create an employee object from employee instantiating employee class, and you can set its name to John by using the set name method. Inheritance. So inheritance is a mechanism where a new class inherits the properties and behaviors of an existing class. So in Java, you can use the extends keyword for inheritance, and this concept definitely helps in code reusability and method overriding. So when a child class inherits from a parent class, it can also override methods of the parent class and provide specific implementation. So if we look at this example, we have this vehicle class, and this vehicle class is a base class that defines a start method. And we have this car class that extends a vehicle. Since we are using extend keyword, it means that car class is inheriting vehicle classes methods and overrides the start method to provide specific implementation for a car. So when start is called on a car object, it will output car is starting instead of vehicle is starting. So we are demonstrating that method overriding and inheritance through this example. Polymorphism. So polymorphism in Java basically allow you to perform a single action in different ways. And there are two types of polymorphism. First one is compile time polymorphism, and second is runtime polymorphism. And this compile time polymorphism is achieved through method overloading, while runtime polymorphism is achieved through method overriding. It's a very powerful concept that lets users interact with objects. What I mean user, that I mean developers interact with object without knowing their exact types, simplifying code and enhancing flexibility. So here is an example. So we have this calculator class, which demonstrates method overloading with two add methods, and they only differ in their parameter types. We see that the first add, it accepts two integer a and b and returns integer as a return value. The second add accepts two double a and b and then returns double. So let's look at animal class. This animal class has a sound method, and upon calling the sound method, it's gonna print animal makes a sound. We have this dog class that overrides this, it extends, it inherits from animal class and overrides this sound method to provide a specific implementation. So when sound is called on an animal reference pointing to a dog object, you will get dog barks as an output. So this demonstrates that dynamic polymorphism through method overriding. Abstraction. This is the last one. Abstraction is about hiding complex details and showing only the essential features of the object. So in Java, abstraction can be achieved using abstract classes and interfaces. So an abstract class cannot be instantiated and can include abstract methods, which are methods without a body. Interfaces, on the other hand, allow to define a contract for what a class can do without specifying how it does it. So let's look at this simple example. We have this shape class, but because we have this abstract keyword, it's a shape abstract class. And shape abstract class cannot be itself cannot be instantiated, requires subclasses to provide implementations for the draw method. So we have this circle class that extends shape and provide its own draw method. If we are to look at interface, we have drawable interface that defines a draw method, and this must be implemented by any class that implements it. So if we look at this rectangle class, we can see that rectangle class implements drawable and provides an implementation for the draw method. Conclusion: to conclude, we looked at the Java's object-oriented programming concepts, and they are crucial for building robust and efficient software. Just for recap, encapsulation helps protect your data, inheritance enables code reuse, polymorphism allows for flexibility, and abstraction hides complexity. By using these principles, you can build more sophisticated software systems, and we will kind of look at each topic more in detail in a different lecture. Thank you everyone for listening.